All right, in today's warm-up, they want us to solve some equations. Again, I know we're working on inequalities, but there's such a similarity between inequalities and equations, so practicing solving equations is still going to help us in this inequalities unit. So we have 4y minus 14 equals negative 10. So we need to start by adding 14 to both sides. So we get 4y equals 4. Then divide both sides by 4, and we get y equals 1. Number 2, 7 times the quantity 2 plus x equals 28. We need to distribute on the left-hand side. 7 times 2 is 14, plus 7 times x is 7x equals 28. Subtract 14 from both sides. 7x equals 14. Divide both sides by 7, and we get x equals 2. The number 3, we have 3 times the quantity x plus 4 minus 5 times the quantity x minus 1 equals 5. So on the left-hand side, we have two distributions that need to happen. 3 times x is 3x, 3 times 4 is plus 12. Negative 5 times x is negative 5x. Negative 5 times negative 1 is plus 5 equals 5. Now we have two sets of like terms on that left-hand side. We need to combine the 3x and the negative 5x, and we need to combine the 12 and the positive 5. 3x minus 5x is negative 2x. 12 plus 5 is 17, so plus 17 equals 5. Remember, when they're on the same side of the equal sign, we are just combining like terms. Then we are subtracting 17 from both sides. So negative 2x equals negative 12. Divide both sides by negative 2. And we get x equals 6. But again, it's about knowing when are we combining like terms and when do I have to do the opposite. I only do the opposite when I'm crossing over the equal sign. Now we are going to return, I believe we're going to be on page 9 today. We're still in the notes solving one-step inequalities. So we're going to go to page 9 to continue with that. All right, so here's the two rules for solving one step with addition and subtraction and solving one step with multiplication and division. Really the nice part is these rules for the most part are the same as when we were solving equations. We're still going to undo them in the same order and all that. The only difference that happens when we are solving inequalities versus equations is if we have to multiply or divide by a negative number. So we're going to add a little note in here. When multiplying or dividing, both sides by a negative number, you must reverse the inequality symbol. And I'll give you an example in just a moment. So for example, if we have something like negative 2x is greater than or equal to 6. In solving this, because it's multiplication, we would undo multiplication with division, so we would divide both sides by negative 2. When we do that, that inequality symbol is going to go from greater than or equal. We're going to flip it the other direction. It's going to become less than or equal to. So this becomes x is less than or equal to negative 3. So we have to pay attention. The inequality started off as greater than or equal to, but because we divided by a negative, it changes the direction of the inequality symbol. And that's a very key step. That is really the only difference in solving inequalities versus solving equations, is that little step if you multiply or divide by a negative. Now, it doesn't mean if there's already a negative in the problem, if there's a negative 8 and you're dividing by positive 2, that does not switch it. It only switches if the number you are multiplying by or dividing by is a negative, like in this case right here. Okay, so that is a rule that we need to be aware of. All right, so now let's look at some problems here. So they want us to solve each inequality. So this first one here, we have x minus 10 is less than 15. And again, since we are going to follow the same steps as solving equations, so Valentina, if I have x minus 10 is less than 15, what do I need to do to both sides to get x by itself? I need to add 10 to both sides. So the same as we would do in solving an equation, we're going to undo the math that we see. In this case, it's a minus 10, so we're going to plus 10. So we get x is less than 25. All right, question B, negative 9 plus x is less than or equal to 16. Aurelie, what do I need to do to get that x by itself? I'm going to add 9 to both sides. That's a minus 9, so I'm going to add 9 to both sides. So I get x is less than or equal to 25. All right, Isaac Alcantara on problem C, x plus 24 is greater than or equal to 61. What do I need to do to both sides? I need to subtract 24. And Melody, what do I get when I take 61 minus 24? not quite 46. If we take 20 from 61, that would get us to 41, and then I need to take another 4 away from 41, so where would I be? So again, 20 of that would take me down to 41, and if I have to take away another 4 from 41, where am I at? Just put in 41 minus 4 into your calculator. 37. So x would be greater than or equal to 37. Again, subtracting does not change the direction of the inequality symbol. We subtracted 24, but it still stays a greater than or equal to. We only reverse when it comes down to multiplying or dividing by a negative number. All right, problem D, negative 2/5 times x is less than or equal to 11. Briseis, what would I need to do to both sides here? If we're gonna and fractions are a little tricky. This is actually a multiplication problem, so we are dividing. Now with fractions we do invert and multiply, but I've been having you guys just go ahead and show it as division so we don't get confused. So we're going to divide by the negative 2/5. So x is less than or equal, and actually we divided by a negative, so we've got to go from less than or equal to greater than or equal. Because we're dividing by a negative, we're reversing that inequality symbol, and that is 11 over 1 times, because we don't really divide, we invert and multiply, times negative 5 over 2. So we change our division to multiplication and we invert our fraction. So x is greater than or equal to negative 55 halves. But again, we divided by, whether you say we divided by negative fifths or we multiplied by negative 5 halves, we multiplied or divided by a negative number, so we need to reverse that inequality symbol the other direction. It started out less than or equal to, so we need it to end up greater than or equal to. And really, we can leave our answer as negative 55 halves. It can't be reduced. Yes, you could turn it into a mixed number, but you don't have to. We could just leave it like it is. All right, number 20. Ethan, what do I need to do to both sides? Yeah, we're multiplying 20 times x, so we're dividing. So x is less than 4 divided by 20, which can be reduced. I can reduce these both by 4. So Michael, if I reduce both of those by 4, what do I have left? X is less than what? 1 over 5. So x is less than 1/5. And then problem F, x divided by 4 is greater than or equal to negative 8. So Maria, what do I need to do here to both sides of this inequality? If I have x divided by 4. So we multiply both sides by 4 to undo the division. So x is greater than or equal to negative 32. Again, we do not reverse the inequality symbol because the negative was with the 8. That's not what we multiplied or divided both sides by. We multiplied by a positive 4, so we do not reverse the inequality symbol there. All right, on the next page, we have some word problems. Now, yesterday's notes, the word problems we have, we were just writing the equations. Today, we're not just writing the equations. We're going to do the whole thing, solve it, answer it in context of the problem, all of that good stuff. All right, so our first one, Supreme Court. The first Chief Justice of the U.S. Supreme Court, John Jay, served 2,079 days as Chief Justice. He served 10,460 days, 63 days fewer than John Marshall, who served as Supreme Court Chief Justice for the longest period of time. How many days must the current Supreme Court Justice, John Roberts, served to surpass John Marshall's record of service? So they don't tell us what John Marshall's record of service is. So we're going to let x equal John Marshall's service. And again, we know John Jay's service was 2,079 and that it was 10,460 days fewer than John Marshall. So if I take x minus 10,463, it's got to be greater than or equal to 2,079. And then I'm solving an inequality here. So it's a minus 10,463. I'm going to add 10,463 to both sides, which means that x has to be greater than or equal. If I add 2,079 and 10,463, I get 12,542, which means the current Supreme Court Justice is going to have to serve at least 12,542 days to surpass John Marshall's record of service. So John Roberts must serve at least 12,542 days as Chief Justice to surpass John Marshall's record of service. And just to let you know, as of today, John Roberts started serving as the Chief Justice on September 29th, 2005. And as of today, November 13th, 2025, that gives him 7,353 days that he has served. So he is still over 5,000 days away from that record. And yet that's over 20 years that he's already been the Chief Justice, just to show you how long that John Marshall had to have been in service. All right, the next one, school. Gilberto earned these scores on the first 3 tests in biology this term: 86, 88, and 78. What is the lowest score that Gilberto can earn on the 4th and final test of the term if he wants to have an average of at least 83? So we're going to say let X equal the 4th biology test. And again, how we get an average is we add up everything and divide by the number of items. In this case, there's 4 tests we're talking about, so we're going to divide by 4. So 3 of the 4 we know, so we're going to take 86 plus 88 plus 78, and then plus X, what that unknown 4th score is at the moment. To average that, we would have to divide all of that by 4, and he wants to have an average of at least 83, which means it needs to be greater than or equal to 83. All right, so we have to take 86 plus 88 plus 78. What do we get when we add the 3 scores that we know about? 86 plus 88 plus 78. What does that come out to equal? Anyone, what do we get when we take 86 plus 88 plus 78? 252. So 252 plus X divided by 4 needs to be greater than or equal to 83. So now that we've combined like terms, now the entire left side is a fraction. So I can't get to the numerator until I deal with the denominator. So in this case, we have to start by multiplying both sides by 4. So 252 plus X is greater than or equal to, what do we get with 83 times 4? 332. So we've got 252 plus X has to be greater than or equal to 332. So now I can subtract my 252 from both sides. And X has to be greater than or equal to what? What is 332 minus 252? 80. So X has to be greater than or equal to 80. So now we have to answer in context. So Gilberto must earn at least an 80 on the 4th test to have an average of at least 83. So again, on the homework you're going to get for this second part of the notes, the word problems, you have to solve them. And then you need to make sure you're answering in context of the problem. The answer isn't x is greater than or equal to 80. It's what does that represent in this particular problem. So we have to make sure we are answering in that context.